Mass of this rigid, okay, this capital M, no, let me write M naught, I'll write it so it'll be easy for me because small m I may go wrong. M naught and radius R. This is a rough surface. Oh, you are able to understand the diagram. Now, what is this? This is a tube. This is a pipe, uniform cylindrical pipe. Let's get into the, so it is the particle will be displaced towards left. So what is the state of the left spring? Will be compressed. So how the spring force will be towards right? This is elongated. So spring force will be like this. So this is compressed. So here the spring force on the disk in what direction? On the particle I have shown. Now let me show on the disk. This is the idea of the problem. The spring is compressed. So spring force. Are you able to notice here? No? I'll show by different colors so that now you can see clearly. Black. Okay, agree, no? This is compressed, this is elongated, so elongated spring force will be there. We are not bothered now the block. Let's bother about the pipe, and this particular edge is connected to the pipe. So what is the spring force acting on the pipe? Kx will be towards left, so that will accelerate the center of mass. That will accelerate the center of mass. So same thing, so some rough diagram. Okay, spring force will be Kx, How the rolling friction should act here? Should act backward. Acceleration of center of mass. How the torque should be about center of mass. Will there be any torque due to spring force? No, spring force will intersect axis of rotation. There's an initial setup. Okay, now the moment I release it, what are the forces that will be acting? The weight of this also will act. No, I need AC. I'll show it here. That of the particle. The particle will be. This is very important. Okay, now look at the. We'll describe the motion of translated motion of the pipe. We'll discuss. Cylindrical pipe, tube and pipe are different here. So on you can say cylindrical pipe will discuss what are the what is the motion of that one. So shall I write 2kx minus f equal to ma on motion of m naught a should be equal to how much? 2kx minus f. This I call equation 1. Let's go for torque. Torque on system about C should be equal to mgx. X is the distance, this one. Okay, this I can't show all the things. So X I'm showing in the left diagram and mg is what we have here. So mg into X and okay, let me proceed like this. Mg into X. F into R should be equal to m naught cylindrical pipe m naught R square plus mx square into alpha c. Try to see this. This is very important. The torque. About center of mass, the friction will set up small r into F anti-clockwise. This weight mg into X, this distance is X, plus m naught g will also act, the weight of the cylindrical pipe, m naught g. It will intersect axis of rotation. There will be normal contact that will intersect axis of rotation. Spring force, they will intersect axis of rotation. And for pure rolling, AC should be equal to R alpha C.
The total system is rotating, sir.
Oh, yeah.
Okay, sir.
Can slide inside the tube. Okay, this fine. The total system is what will rotate now at that instant, will have tendency to rotate.
Why will it rotate about the center, sir?
Tell me like which point you want it to make to rotate.
About the center of mass.
No, it is there is that tube is there, no? It's a light tube, and look at the bead. It's like a bead, that one, a bead of massam connected by two identical strings, each connected. Inside that tube, it's there. So you want to say about center of mass of system.
So, the system has natural tendency to rotate about the center of mass.
No, this is not natural tendency. No, there's a normal contact. Everyone is there. If it is set free to rotate center of mass, but here the ground will put some constraint here. No? It is not free to rotate. Okay.
Okay, sir.
You have to solve equation 1, 2, 3. I'll write down the answer. Check once. AC is equal to 2, what are K R square plus mg R into X.
A r square, sir. Dimensionally, it will not be.
It will be
2K
KR,
R
sir.
square plus M.
So in the numerator, it should be 2KR, sir.
2KR. Check once answer. if you try to solve it. So aggression of, find aggression of center
KR, sir.
2 kr only. Yeah, okay. Yeah.